Welcome to this explainer. If you are an infrastructure admin gearing up for the Nutanix Certified Professional Multi-Cloud Infrastructure, or NCP-MCI 7.5 exam, well, you are exactly where you need to be. Today, we're locking in on a highly testable subtopic, NCP-MCI 7.5 to 8.6 volumes, requirements, and limitations. Knowing how to deploy volumes is great, but understanding its strict boundaries? That's what's going to actually pass you the exam. So grab your notes, get comfortable, and let's master this together.
Here is our roadmap for today. We're going to hit 1. Why Nutanix volumes matters, 2. A quick walkthrough with examples, 3. Those sneaky common exam traps, and 4. The key facts you just absolutely have to memorize. All right, Section 1. Why Nutanix volumes matters. Let's set the stage and figure out exactly what this feature is meant to do in the real world.
So, at its absolute foundation, what is Nutanix volumes? It basically acts as one or more iSCSI targets for client Windows or Linux operating systems. But here's the crucial distinction you have to keep in mind. Those operating systems can be running on a traditional bare metal server, or they can be guest virtual machines, meaning VMs. By defining volumes specifically as an iSCSI target for guest VMs and bare metal clients, we immediately see its purpose. It's the essential bridge for external storage, letting these clients consume Nutanix cluster storage directly over the network, kind of like a traditional storage area network, or SAN, but you get all the distributed goodness of the Nutanix architecture.
And it's honestly pretty amazing when you look at the sheer enterprise-grade workloads this thing handles. Look at the OS side. You've got the heavyweights, Windows Server, Red Hat Enterprise Linux, CentOS, even Oracle Solaris on Spark. Then check out the qualified apps. We're talking Oracle Real Application Clusters, Microsoft SQL Server, Exchange, Linux guest clusters. This isn't just for, lightweight file sharing. It's literally built to support those heavy-hitting Tier 1 applications that absolutely demand robust, shared block storage.
Moving right along to Section 2, Volumes, Walkthrough, and Examples. Let's connect the dots on how this actually works under the hood.
Okay, pay attention, because this is a massive exam point. You need to firmly contrast the right way to do things with the very, very wrong way. The absolute best practice? Connect your clients using the single iSCSI data services IP address. That one single IP acts as your target discovery portal. The bad practice, which, trust me, will earn you a swift fail on a scenario question and a massive headache in real life, is configuring your iSCSI clients to connect directly to individual controller VM or CVM IP addresses. Hard-coding those CVM IPs is incredibly brittle, it's unsupported, and honestly, it completely defeats the purpose of having a distributed system in the first place.
And the why behind this is beautifully simple: high availability. The iSCSI data services IP is a floating address. Basically, only one CVM owns that data services address at any given moment. So if that owner CVM goes down for maintenance or just crashes, that IP seamlessly floats right over to a surviving CVM automatically. The result? Your storage stays online, and you don't have to scramble to manually update every single iSCSI initiator on your network.
Let's make this totally concrete. Imagine you're Allowlisting a Windows client to access this storage. First, you'd pull up your Windows administrative tools. Second, open the iSCSI initiator properties. Third, and this is the absolute key step, you locate and copy that unique iSCSI qualified name, the IQN. Finally, back in your Nutanix cluster UI, you plug in that unique IQN, not the IP address, to Allowlist the client.
Why the IQN and not the IP? Well, it's all about strict identity management. The official docs actually spelled this out, saying each initiator IQN must be unique. Connections from two clients with the same initiator IQN might result in undesirable behavior. IP addresses can change, right? DHCP leases expire, IPs can get spoofed. But an IQN is a rock-solid, unique fingerprint for that specific initiator. It guarantees the cluster never gets confused, keeping your I/O paths cleanly separated and secure.
All right, shift your mindset now. Section 3, Common NCP-MCI Exam Traps. We're entering the danger zone. To pass, you need to know exactly what Nutanix volumes cannot do.
If you remember literally one thing from this entire explainer, please let it be this exact quote from the documentation. Important: do not use Nutanix volumes to create an iSCSI data store to Hyper-V or ESXi hosts. This configuration is not supported. I really cannot stress this enough. Volumes is strictly for in-guest operating systems and bare metal servers. Never, ever use it to provision data stores for hypervisors. The exam creators absolutely love to trick you with this. They'll give you a scenario like, hey, an admin needs to add storage to an ESXi cluster, and decides to expose a Nutanix volume group over iSCSI directly to the ESXi hosts. Then they'll ask you how to configure it. It's a trap. The answer is always that it is strictly unsupported. Nutanix provides native storage to the hypervisor. Volumes is for the clients running on top of or entirely outside of that virtualized layer.
On top of that, there are a few more hard binary limitations you just have to know. IBM PowerHA cluster configurations, completely unsupported. As we just hammered home, iSCSI data stores to ESXi or Hyper-V hosts are a hard no. You also cannot boot from SAN using the NVMe over Fabric's TCP protocol. And lastly, there is a hard scale limit. You cannot present more than 32 vDisks via virtual targets. 32 is your absolute maximum. So if an exam question tries to sneak in 33 vDisks, you know it's a fail.
Almost there. Section 4. Key facts to memorize. Let's do a rapid-fire review to really anchor this into your short-term memory before test day.
If they ask you about network requirements, specifically which ports need to be open between the iSCSI client initiators and the cluster targets, the default TCP port is 3260. Burn that number into your brain. If a firewall blocks 3260, your clients simply won't connect. Port 3260. Memorize it.
Okay, take a mental screenshot of this list right now. These are your absolute non-negotiables. 1. Default TCP port is 3260. 2. Always Allowlist clients using unique IQNs, never IPs. 3. Absolutely no volumes for ESXi or Hyper-V data stores. 4. IBM PowerHA is completely unsupported. And 5. You max out at exactly 32 vDisks via virtual targets. Know these cold, and you will crush any volumes question they throw your way.
Let's wrap things up with a mock exam scenario to test your instincts. An administrator attempts to use the iSCSI Data Services IP to mount a new VMFS or Virtual Machine File System data store directly to a vSphere cluster. Why will this configuration fail? Well, if you instantly thought because Nutanix Volumes does not support creating iSCSI data stores to ESXi hosts, then you nailed it and you are totally prepared. Keep these boundaries fresh for test day. But you know, it does leave us with an interesting thought. As modern infrastructure continues to blur the lines between virtualized compute and storage, what other legacy bare metal storage paradigms are destined to become completely obsolete next? Thanks for hanging out for this explainer, and good luck on your NCP-MCI certification.